We are going to continue on talking about concentrations, and the next concentration that we're going to talk about is molarity. Previously, we had talked about percent concentrations where we had mass percent, volume percent, and mass volume percent. Note that all of these were multiplied by 100, so they are a percentage. This is not the case with molarity, which is what we're going to learn about now. Molarity is moles of solute over liters of solution. And note, there's no multiplied by 100. The abbreviation for molarity is capital M. And it's moles per liter. So one of the things that you need to remember is how to convert grams to moles. So grams to moles, this conversion can be carried out using the molar mass. So you have so many grams of something. So let's say we have X grams of something over 1. We're going to convert it to moles by dividing by the molar mass. So this is the molar mass. So divide by molar mass. Now the other thing you need to know how to do in order to do molarity problems is to convert milliliters to liters. So milliliters to liters, if you start off in, let's say, 362 milliliters, and I want to know how many liters that is, remember we can move the decimal, so you can move the decimal using that prefix ladder. The decimal right now is here, and I'm going to move the decimal 1, 2, 3 to the left, or it's the same as dividing by 1,000. Okay, so that gives us 0.362 liters. So molarity can be used as a conversion factor, much like we use the percent concentration. So how many moles of HCl are there in 32 milliliters of a 3.0 molar solution? This is the conversion factor, and the conversion factor looks like this: 3.0 moles over 1 liter. So my starting quantity is going to be here. So I'm going to say 32 milliliters over 1. I'm going to go from milliliters to liters to moles. So 1,000 milliliters. You can convert from milliliters to liters by moving the decimal to the left like we did up here, or dividing by 1,000. I like to divide by 1,000 in this case because I can do my conversions in one fell swoop. Some students like to break it up, and that's fine. Now this conversion factor up here, we need liters to be on the bottom and moles to be on the top, so it's perfect. I use it as is. I pull it out from here and put it right here. So 3.0 moles over 1 liter. So I get 32 divided by 1,000 times 3. I end up with 0.096 moles. Okay? So that's a case where we use molarity as a conversion factor. We're going to do the same thing here. Molarity as a conversion factor, 10.2 moles over 1 liter. 21 grams will be my starting quantity. So this is conversion factor. So I need to get to liters of solution. So I'm starting out with grams. I'm going to get to liters, so I need to go grams to moles to liters. So 21 grams over 1. I need to find the molar mass of HCl. Hydrogen's 1.008 plus 35.45. I'm getting this off the periodic table. These are the molar masses. 1.008, or sorry, it's the atomic weight from the periodic table. So we get 36.46 grams per mole. So 36.46 grams divided, so we divide that, and our grams cancels out. We've got all this to cancel out up here. So now we're in moles. I'm going to use this conversion factor. We need moles on the bottom. So I'm going to have to flip it. So 1 liter goes on top, 10.2 moles on the bottom. Cancel, cancel. So in my calculator, I'm going to enter 21 divided by 36.46 divided by 10.2. And I end up with 0.056 liters. So remember, molarity is not a percent concentration. It's not out of 100. You just take it out of 1 liter. So on the next page, I have several practice problems for you to do. And the first one involved asking directly what the molarity is. Actually, the first 3. So the first 3 all involve asking the molarity. Remember that molarity is moles over liters. So we have 160 milliliters, so 0.160, and then the moles, I'm going to have to calculate 0.0 grams divided by 337 grams over 1 mole. 50 divided by 337, end up with 0.148. It's going to be 0.148 divided by 0.160. So that will equal 0.925. And the units on that would be molarity. So capital M, or you can write moles/liters. So in question 2, you're asked to calculate the molarity again. So I always like to write capital M equals so many moles over liters. You're given the moles, and the liters are given here, 200 milliliters. So 200 milliliters is 0.200 liters, 0 liters. So 0.1 divided by 0.2, you get 0.5, and you would have your answer expressed like that. So question 3, again, you're asked molarity. You're given grams, molar mass, and milliliters. So the moles over the liters. You're going to have to convert milliliters. So divide by 1,000 and move the decimal to the left 3 times. So you end up with 0.1250. And sometimes if I have a 0 after the decimal or not after the decimal, that has to do with significant figures, which we don't go into in this class. So it's not something that I stress greatly. Okay, right now we have grams and we have grams. We do not have moles. So we have to convert 22.42 grams, divide that by 119 grams. It goes like that. So 22.42 divided by 119, we get 0.188. Yeah, I'll say 4 moles. And then you'll just divide that out. So 0.1884 divided by 0.125, so you end up with 0.1507 molar. And lastly, we have 2 problems, numbers 4 and 5, that you're supposed to use molarity like a conversion factor. So remember, molarity is not taken out of 100, it's just taken out of 1. This next problem is just a molarity one. You're asked to calculate the molarity. So we're going to do a conversion problem where this is our starting quantity and this is our conversion factor. So we have 24.446 grams calcium nitrate. Remember, calcium nitrate looks like that. And we need to get it to milliliters of solution. So we're going to go grams to moles, moles to liters, liters to milliliters. Now, I did not provide the molar mass for you. I would normally provide the molar mass, so I'll calculate it for you really quickly. Calcium's 40, and nitrogen is 14.01. We have 2 of those, plus, then we have 6 oxygens, so 6 times 16. So you end up with a molar mass of 164.1. So I'm going to divide 164.1. Then I'll use this conversion factor. I can take it, if I take it exactly like it is, I'll get moles squared. So I have to flip it. And then I can convert liters to milliliters. So 1 liter is 1,000 milliliters. So I'm going to divide if it's on the bottom, multiply if it's on the top. So you end up with 331 milliliters. And the last problem, again, asks for molarity. So when you're asked for molarity, just put that big M, moles over liters. So your liters, you're going to convert your milliliters to liters. So it's like that. You're going to have to figure out the molar mass of sulfuric acid. So 1.008 plus 1.008 plus 32.06 plus 16 times 4 gives you 98.08 grams per mole. So I'm going to take 2.355 grams. Cannot put the grams directly in there, it's not in the right units. So I have to divide 98.08 grams over 1 mole. 2.355 divided by 98.08. You end up with 0.0240 moles. And then you're going to divide that out, and you end up with 0.48 molar. So with these problems, concentration problems, percent concentration, and molarity problems, it's really important that you practice. So practice, 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 do your homework problems, and then you should be set. That concludes Unit 4. Great job.